My dear students, in my today's class, we are going to discuss motion in curvilinear plane. Okay, this is a part of kinematics only. It will be concept number 10. Okay, and lecture number 1. Okay, this is the first lecture, motion in curvilinear plane. And as you know, my name is Amarjyoti Nath. Okay, so let's curvilinear motion. Okay, see, first of all, we should understand one thing. So this is some ordinary path, okay? Well, a particle is going, okay? So actually, what happens, you see, the speed of the particle may increase, okay? Say here the speed is little bit less, here speed is more. It means that will be an accelerated motion, okay? AT means tangential acceleration. Acceleration actually happens only when the speed changes, okay? Tangential acceleration occurs only when the speed changes. But you understand here actually the direction is also changing, you know. Direction is also changing. So if direction changes. So as you know the direction only, okay. So that because of the direction change, so whatever acceleration occurs, that acceleration is called centripetal acceleration, okay. Remember centripetal acceleration is always towards the center. Well, always towards the center of the curve, okay. I'll write all these things. And net acceleration is just vector sum of tangential acceleration and centripetal acceleration only. Okay. So first of all, how can I get net acceleration? Okay. So how can I get net acceleration? I get net acceleration A is just by differentiating the velocity vector. Okay. It means if you differentiate a velocity vector, remember that is velocity vector, okay? So what you get? You get net acceleration. It means this is nothing but the rate of change of velocity vector, okay? Velocity or velocity vector. Now, acceleration is of two types, okay? There are two types of acceleration. Is of two types. Two types. Two types. Number one, that is called tangential acceleration. Tangential acceleration. So tangential acceleration symbol is AT. Okay. And what is tangential acceleration? Tangential acceleration is rate of change of speed. You see, I repeat, velocity may be changed by two ways. Okay. If direction changes, then also velocity changes. If speed changes, then also velocity changes. So tangential acceleration is because of change of speed. And the other acceleration that is called centripetal acceleration, it will be because of change in direction. Okay. All these things, no need to worry about it. So if the speed changes, say here the speed is 5 meter per second, here 6 meter per second, here 7 meter per second. So speed is changing. No? So it means rate of change of speed. Remember, speed is what? Magnitude of velocity. So you please try to understand all these two. Remember. See, this is AT. It is nothing but DDT of modulus of velocity. But here it is, you see, modulus is not there. Okay. So if modulus is not there, it means it is uh, that one net acceleration. But if you differentiate only the magnitude, then it is called tangential acceleration. Okay. So tangential acceleration is also vector quantity. Okay. All accelerations are vector quantity. So tangential acceleration is vector quantity. So each direction will be tangentially forward if speed increases, or it will be tangentially backward if speed decreases. Okay. The direction will be what? Direction tangentially forward if speed increases. Okay, say the speed along this path equal to, say, v equal to 2t. Okay, so v equal to 2 into t means what? Speed is increasing, na? So it means tangential acceleration will be tangentially forward. Equal to speed equal to 5 upon t. It means what? If time increases, so speed will be decreasing, na? So though the particle will be going along this line, but tangential acceleration will be backward only. Okay, it means someone is pulling it so that its speed decreases. Okay, so tangentially forward if speed increases, and tangentially backward if speed decreases. Oh, I think second part should not be written. Na? You understood all these things. Okay. And second acceleration is called, that is centripetal acceleration. Centripetal. And this is also called normal acceleration. Normal. Symbol is AC or AN. Okay, same symbol. So centripetal acceleration is always speed square by radius. So if it is a curve, okay, if it is a curve, so it will have some radius, na? So that radius, okay. So this is important formula. Speed square by radius, okay. And the direction is always towards the center. Direction always towards the center, okay. So remember, we have got three formulae till now. Velocity differentiation, net acceleration. Magnitude of velocity differentiation, tangential acceleration. And speed square by radius is centripetal acceleration. And that can also be written as like this also, you see. Speed is nothing but magnitude, na? So this is square by r, okay? Like that also I can write. Same thing. Both are same only, okay? And direction of acceleration, centripetal acceleration is always towards the center, okay? Center. Okay? So net acceleration can be written this way also. Net acceleration, A vector is equal to AT vector plus AC vector. Okay, you please write this also. Net acceleration. And if you want to know magnitude of net acceleration, okay, magnitude. So if you want to know the magnitude of net acceleration, so it will be equal to what? Magnitude of centripetal acceleration plus magnitude of tangential acceleration. Because they are perpendicular, no? Because AT and AC are perpendicular, because AC is towards the center and AT is tangent, radius is always perpendicular to tangent. So they are 90 degrees to each other, AT and AC. So if you square and adding, you are going to get a magnitude of net acceleration. Okay. So you write all these things. That is called magnitude of net acceleration.
Done, sir.
Okay. I'm taking this question. Huh? You just try to follow what I'm doing. Huh? Velocity of a particle moving along curvilinear path in xy plane is Vx equal to 2, Vy equal to 2t. Okay. Uh, say this is x-axis. Well, this is, say, y-axis. The particle is going somewhere. Okay, like this. Okay, whatever it may be. But Vx is 2. So it means I can write that velocity as a general. It is nothing but Vx I cap plus Vy j cap. Okay, this is the in general formula. Okay? Vx is 2. I cap is just direction. Okay. Well, so now they are asking find its tangential acceleration at t equal to 1 second. Find its centripetal acceleration at t equal to 1 second. Then they are asking find its net acceleration. Nothing is written means net acceleration. Find its net acceleration at t equal to 1 second. And then they are asking find its radius of curvature at t equal to 1 second. Okay. Radius, say t equal to 1 second, the particle is at this point. Okay. Say at t equal to 1 second, particle is at this point. So what will be the radius of curvature? Radius of curvature means if you make a circle, okay, if you make a circle taking this curve, so what will be the that one radius of the circle? Okay, that is called radius of curvature. So I'm going to do step by step all these things. Okay, just you try to follow it only. Okay, solution. First, uh, we know acceleration equal to differentiation of velocity vector. Okay, so it means what? Differentiation of 2 I cap plus 2 into t j cap. Okay, so acceleration vector equal to, now you see that there is a constant term. Okay, 2 is a constant term only. No? 2, 3, 4, all are constant. So what will be the differentiation of 2? It will be 0. I cap is just direction. Okay? 0 I cap means no direction, no component along x. Plus, what is the differentiation of 2t? You understood, no? ddt of 2t is nothing but 2 only, because it will be 2 into dt by dt. No? dt by dt is 1 only. Okay, so it will be 2 j cap. So I hope you know the differentiation part. Okay, so the net acceleration will be what? Net acceleration will be 2 j cap. So this is the answer. Can you say me which answer is this? Is it? It is this. And remember, they are asking at t equal to 1 second. Remember, they are asking at t equal to 1 second. But you see, in my expression, there is no any t. So what does it mean? It means that it is dependent. At t equal to 1 second also, acceleration will be 2j. At t equal to 2 second also, acceleration will be 2j. Okay. And what is acceleration? Acceleration means that one. Okay. 2j means what? The acceleration will be in the direction of that y-axis. Okay. Nothing else. It is like this only. Okay. So I have already that one calculated the question number 3. Now let me try the tangential acceleration. Okay. So again, I know at equal to ddt of magnitude of velocity. Okay. So here you see velocity is this. So what is the magnitude of this? It is nothing but 2 2s are 4. 2 square is 4. And this is 4t square. Okay. 4t square. Or you can write it as 2 under root 1 plus t square. Okay. Do you have any doubt in this? So here at will be what? At will be ddt of 2 can be taken out, no issue. 2 into 1 plus t square, as it is under root, it is under root, so it will be half. Okay. So I have to differentiate this. Okay. This is a little bit big differentiation, but I hope till now you understood. Okay. In mathematics also, I think you have already started discussing all these things. Okay. So that part differentiation, see, I'll do it separately. Okay. So this is something, say this is x. Okay. So x to the power half means what? That half will, that coefficient, half will be coming as coefficient. Okay. 1 plus t square, that is x. Okay. And half minus 1 is minus half. Okay. And again, I have to differentiate this part. Now that differentiation will be 2 into t. Remember, it will be a little bit big differentiation. Okay, so 2 will get cancelled. So at equal to so your at will be what? 2 into t by under root 1 plus t square. Okay, so this is the expression of tangential acceleration. Remember, this is the expression of tangential acceleration. It is the expression of net acceleration. It is the expression. And now you see tangential acceleration is not constant. It is time dependent. You see, at different time it will be different. So what they are asking at t equal to 1 second. So at t equal to 1 second. So at will be v. And here it is. This is also 1, na? 1 plus 1, 2, under 2. So it means at will be root 2. Okay, this is root 2. At t equal to 1 second, tangential acceleration is root 2. Okay, that is done. Second question, but this part is done. This part is done. So you please try to understand once more. If you have any doubt, then I can help you. You see, actually you are differentiating ddt of 1 plus t square to the power something. Okay, say something is n is half. So you know the differentiation, na? That n comes down, na? Like that. So it comes down, and this is something x. Okay, so that n minus 1, n minus 1 is half minus 1. So half minus 1 means what? It will be minus half only. But again, you have to differentiate this part actually. That is called 2 into t. But here actually one additionally 2 was there, na? That one additionally 2 was there, na? That 2. Okay, that 2. In the question, in the speed, that is 2, na? So you have to multiply by 2 also. Okay, so that 2 also will get cancelled. That is 2. So here also it will be 2. Okay, so this 2 will get cancelled. So ultimately you are going to get 2t by, that is 1 plus t square to the power half. To the power half means under root. Okay, so this part actually you check once more. Okay, you do yourself. Okay, so if you find any trouble, so that is acceleration tendency. Remember, tangential acceleration little bit complicated only. Okay, in future also you are going to get like this only. Anyway, so this is tangential acceleration. Now, what they are asking? They are asking centripetal acceleration. Okay, they are asking centripetal acceleration. So centripetal acceleration, how can we calculate? You see, we have two ways. Okay, to calculate centripetal acceleration. So I hope you have copied this part. Okay, so again, centripetal acceleration is what? Speed square by r. Okay, I can calculate speed. Okay, at t equal to 1, speed is what? If you put t equal to 1, so 1 plus 1 is 2. The speed will be 2 root 2. The speed will be 2 root 2. Square of 2 root 2 divided by radius, but I don't know radius, na? Because radius is in the question number 4, they are asking radius, so I cannot use this formula. Okay, I will use this formula. You see, I know that a square equal to at square plus ac square. Okay, so from that I know ac square will be net acceleration square minus at square. But net acceleration is what? Net acceleration is 2. 2. Remember, this is 2, huh? Magnitude of net acceleration is 2 only. Okay, so it will be 2 square minus tangential acceleration is what? Root 2. So root 2 square. Okay, so it will be what? It will be 4 minus 4, 4 minus 2. It means it is 2. But remember, AC square is 2. So it means AC will be what? It means AC will be AC square is 2. Huh? Calculation part you check it, huh? Once more. It will be under root 2. Okay, so that part I understood. Which part? That third part. So sorry, not third part, second part. Okay, find the centripetal acceleration at t equal to 1. So what will be the centripetal acceleration? root 2. And everywhere meter per second square, okay? All are having the same unit only, meter per second square. So you see, I have calculated simply total acceleration by differentiating it. Then I calculate the magnitude, okay? Differentiate the magnitude, I get tangential acceleration. Then a square equal to ac square plus at square. I know the vector law, because you see at if like this, ac is perpendicular to it. So net acceleration is always what? By vector law, a square equal to ac square plus at square only, okay? Because they are 90 degrees to each other, na? The components are. Now I need to calculate the radius of curvature, okay? So now I can easily calculate the radius of curvature also. How you see? Now R equal to R equal to speed square by AC. So where from I get this formula? Where from I get this formula?
AC is equal to V squared by R.
Square by R. So R equal to what? Speed square by AC. Now AC I got root 2. Okay. And speed is what? Speed is this much. But I want at t equal to 1. Na? So that also you can write at t equal to 1. Speed b equal to, so that will be 2 root 2. Okay. So that is 2 root 2. But you have to square it also. Na? So it means 2 to the 4. 4 to the 8. 8 by root 2. The answer is 4 root 2. 4 root 2 meter, huh? Because the radius is meter only. Okay. 8 by root 2. Okay. 4 into 2 into 2. 4, 4 into root 2 into root 2. So 1 root 2 get cancelled. You know, I think that this part 8 by root 2 means what? What I have done? I have done 4 into root 2 by root 2. Okay. 1 root 2 got cancelled. So 4 root 2 remains. Okay. So I hope you just understood the sequence chronology. Okay. How we proceed. Okay. In that calculating centripetal acceleration, I have not used speed square by r, because r I don't know. Na? If in the question r is given, so obviously AC will be calculated and other can be asked. Okay, it depends upon the situation. So I'm going to give you a similar question. Are you ready for that?
Yes, sir.
Okay. This is your question. Okay, please write. Please try to solve it. Velocity of a particle moving along curvilinear path in xy plane is given by Vx equal to 3t, Vy equal to 4. Find its tangential acceleration at t equal to 2 seconds. Find its centripetal acceleration at t equal to 2 seconds. Find its acceleration, means net acceleration at 2 seconds. Find its radius of curvature at t equal to 2 seconds. Okay. Okay, here actually velocity is what? Velocity equal to Vx. Vx is 3t. That is I cap. And the Vy is 4 only. Okay. So this is the velocity. Okay. If you want to calculate the magnitude of velocity, so magnitude of velocity is nothing but Vx square plus Vy square. No, not and that one. Okay, so it will be what? Vx is nothing but 3t. So 3t whole square means 90, 9 into t square. Okay. And Vy is 4. 4 square is 16 only. Okay. So this is the speed actually. Okay. It means you can say that this is the magnitude of velocity. Okay. So here acceleration is what? Acceleration is equal to dv by dt. So, and which is equal to what? Differentiation of 3t is 3 and differentiation of 4 is 0. So it means acceleration is 3 only. Okay. Net acceleration is 3. So that is found. And the speed is this, but I need to calculate at. At is nothing but differentiation of magnitude of velocity. Okay. So that is nothing but ddt of, you know that 90 square plus 16 to the power half. Okay. To the power half. So it means this will be equal to, so half will come as a coefficient. So 90 square plus 16 to the power half minus 1. It is minus half only. And again, if you differentiate that 90 square part, you are going to get 18 into t. Okay. 18 into t. 9t square, na? That 2 will come forward, na? So 2 into 9 is 18. So it means AT is nothing but AT is nothing but so G2 and 18 is 9, okay? So it will be 9 into T, and this is to be a minus half. So it means it will come as denominator, no? So 9 T square plus 16, okay? So this is the tangential acceleration. So at T equal to 2, so it will be a very big value, but whatever it may be, I can easily calculate. So 9 into 2 will be 18. And this will be 9 at 2 to the 4, 36, 36 plus it, this is 52. Okay. So that 80 will be this. Okay, 18 by 52. So it will be 2 root 13. Yes. So it means 9 upon root 13. That will be the 80. Okay. 80. So two ends are found. 80 also found, and net acceleration also found. Now what I want the centripetal acceleration. Okay. So centripetal acceleration will be under root net acceleration minus at square only, okay? Just I am rearranging the expression, nothing else. I have already given you, na, the main expression. So it will be what? Net acceleration is 3. 3 square. And 8 is this. It means 9 square by 13. It will be 9 minus 81 by 13. Okay? If I take 13 as LCM, so 9 into 13 means what? 117 minus 81, okay? 6. Am I correct? So I think answer is under
Yes, sir.
it is okay. So this will be the AC. I calculated A, I calculated AT, I calculated now AC. Okay. Then what I need to calculate? I need to calculate radius of curvature. So radius of curvature will be speed square by AC. Okay. Again, R equal to. But the speed is equal to what? At actually at T equal to 2, na? It will be, I think, under 52. Okay. It will be under 52 square. And AC is 6 by under 13. Okay. So it means it will be 52 into under 13 by 6. Okay. So it is 326 root 13. Okay. I think we cannot simplify it more. Okay. Check the calculation part once more. All will be in meter, nothing else. Think of this question. The speed of a particle moving along a circular path of radius 2 by pi meter is given by v equal to 2t. So first you tell me whether the speed is increasing or decreasing.
Increasing, sir.
So now they are asking what is the speed when it goes to diametrically opposite point? What will be the tangential acceleration? What will be the centripetal acceleration? What will be the net acceleration? Okay. If its speed is fixed, so there will be no problem. It will be easy. But now speed is increasing. Na? So this is the point. Okay. Here the particle start moving. Okay. The particle started moving this way. And when it goes to this point, okay, so its speed will be little bit more. Na? So as its speed is increasing, it means tangential acceleration will be in this direction. And as there is a curve, so centripetal acceleration is always towards the center. And net acceleration will be in this direction. Okay. We are going to discuss all. And now this time actually radius of curvature is given. Okay. Radius of curvature is given. This is 2 by pi. Okay. So I don't know exactly at this point what is the speed actually, okay? I don't know. Because here actually time is given. But in the data, they are giving diametrically opposite point, okay? So how to solve it, you see. Uh, Here, V equal to 2 into T. Remember, V is speed here, okay? So if I differentiate the speed, dV by dt, it is not velocity, remember. So it will be 2 only. So it means AT is 2 only, okay? That AT is 2. Here also AT is 2. Here also AT is 2. Here also everywhere. Because it is time independent. AT is 2. Not 2 into T, not 2 into T square, not 2 into T plus something. It is simply 2. So AT is fixed, okay? Direction is changing, but value is fixed. So it means I answered this question, okay? And remember why it is not net acceleration, why it is only tangential acceleration? Because they are giving the speed. This is speed, okay? This is speed, not velocity. Yes? Now you see, with this speed, actually, how much time they will take from here to here, huh? A to B. Let us check it. So V equal to 2 into T. So V means what? Distance by time. Distance by time. Huh? Here S is not displacement, it is distance. 2T. So it means ds equal to what? 2T dt. Okay. So S integrate. Okay. When time was 0, distance was 0. But when time is T, the distance is here to here. Okay. Here to here. It is pi r only, no? Yes or not? 0 to T, 0 to pi r distance. So that part will be pi into r. And this part T dt is nothing but in T square by 2 only. So cut. So from here I understand that T square equal to pi into r. R is 2 by pi. So pi got cancelled. So T equal to under root 2. So what does it mean? It means the particle takes root 2 second from going from A to B. Okay. From A to B, the particle takes root 2 second. The particle takes root 2 second. Root 2 from this. You see, V equal to 2 into T. V means ds by dt. Speed equal to always distance by time. Na? ds by dt. So now you see. So now you can find the speed at the point B. Okay. So speed at the point B will be what? Speed at the point will be 2 into T. But T is root 2. So it means speed at the point is 2 root 2. Okay. But I need to calculate centripetal acceleration at point B. At this point, I need to calculate the centripetal acceleration. So centripetal acceleration is what? It is speed square by radius. So speed square. This much square is what? This much square is 2 to the 4, 4 to the 8. And r is what? 2 by pi. So it means centripetal acceleration will be 4 pi. 4 pi. Centripetal acceleration will be 4 pi. Okay. Tangential acceleration is 2. Centripetal acceleration is 4 pi. So what will be the net acceleration? Net acceleration is under root AC square plus AT square. Okay. Under root AC square means 4 pi square. Remember, pi square value you can take 10 also. No problem. Pi square is nearly always equal to 10 only. Okay. So
Sir, how did you write T square is equal to pi 2 by 2?
T square equal to, because R value is
Pi
by
2 by
pi. Here you see it is pi r equal to T square. Okay. So it means T square equal to pi into R is already given, na, 2 by pi.
Okay, sir.
Okay. So pi got cancelled. Now net acceleration is AC square plus AT square. So AC is 16 pi square. Okay. 16 pi square. And AT square is 4. So if you want, you can write it as 164 only, okay? Because pi square is 10. So 16 pi square is nothing but 160 plus 4, 164, okay? If you can simplify it, no problem. So what you see, what is the speed? I have calculated to be 2 root 2, okay? What will be the tangential acceleration? At the beginning I have calculated is 2. What will be the centripetal acceleration? That is calculated to be 4 pi. What will be the net acceleration? That is calculated to be under root 164.
Sir, how did you calculate VB, sir?
Which part? VB. Speed at this point. Because you see, speed is varying with 2 into t, okay? Speed varies as 2 into t. But at B, t is nothing but root t, 2, na? To reach the point B, the particle, yes or not? So
Yes, sir.
in place of 2t, I have put root 2 because they have taken root 2 time to reach the point B. This point is say B. Okay.
Yes, sir.
Remember, the unique point is that speed is distance by time. Speed is distance by time. Okay. And this is distance. This is distance. 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 Okay. 0 to 1, 2, 3, 4, 5, 6. Karke. So that pi r, pi r, pi r, pi r. You know that half of the circumference is pi r because complete is 2 pi r. So that is why you are integrating from 0 to pi r, 0 to t. When it was here, distance is also 0, time is also 0. When it starts moving, here time is t and distance is pi r. Okay, they are corresponding. Okay. Okay. On that note, so please see all the questions once more. Okay. Give a recap of all this. Okay. And I'll try to send the video also as soon as possible.
Bye, sir.
Bye bye.